Welcome once again. We are here to do some new work, something new about the embedded systems, circuit designing, programming, all the steps. What we are going to do today, we are going to interface the LED with Atmega 16, AVR Atmega 16, which is of Atmel company microcontroller. It is very quite good to learn the very basic steps to do for good programming skills. So what we are going to do, we are going to do interfacing of LED with AVR microcontroller. So first of all, what we need, we have to design the circuitry of AVR microcontroller interfaced with LED. Why first we do circuitry part of thing? Because the hardware is must. Because the hardware is must programming. Without knowing hardware, how you are going to decide which pins is going to be high or which is going to be low. So first we are going to design the hardware. Actually, the Proteus is a tool which I had introduced you before in the previous video. If you want to know how it works, you can go and refer that video. Please, it's a suggestion for you to first learn about the Proteus and then continue this video. So first of all, we have to choose the component. As I had told you before, go to this part list. What we need at Mega 16. What is consist is also display here. It's a 16 kilobyte of flash. It's very quite good for small programmer. SRAM, EEPROM, 520 byte of EEPROM, ADC, inbuilt ADC. It's very good and it's an advantage over 8051 microcontroller. If you want to do IC with 8051, but in this it's inbuilt analog comparator, TWI 2-wire interface. It's also known as I2C, SPI, 4 ports are there, A, B, C and D, 3 timers, 1 UART, and many more things. You can go and refer to the data sheet. For knowing more thing, you can just comment in the video. Then after that, LED. Choosing the LED, you have to focus for this. You have to choose active one, LED, resistors, crystal, external crystal. Every microcontroller works on the clock. For clock, we are using external crystal. Then capacitor, one more capacitor you need, electrolyte capacitor, and SPST switch, single port single throw, which is known as button switch in this process. Button, say SPST, single port single throw switch for reset. If we need any more component, we can again take from here. First we have to design the circuit, then crystal for external external clock. Why we are using external clock? Because it's stable, whether it's the temperature changes or anything else, it is stable all the time. So we are using external crystal. We are using 16 megahertz external crystal. Then capacitor, ground, it's 22 picofarad. Whether you select, it is not case sensitive, it is small letter or capital, it doesn't matter. Now we have to design the reset circuitry. For that you need the resistor, then capacitor, power source, microcontroller, AVR microcontroller maximum is 5 volt, so we are using 5 volt power source. So the reset circuitry, ground. Ground is very necessary. Don't forget to place the ground. It's 10 microfarad here. If you forget the ground, it's very difficult to fetch your error or detect your error. Why the reset circuitry is like this? Because the continuous 5 volt is current is going to the reset, and this capacitor is when fully charged, it works as open circuit. When we have to provide sudden change to the reset pin, we put this button and the circuitry will be reset, and it again starts with the beginning. Now we have to do place the LED with this resistor of 330 kilo ohm. So by default all the values are taken in the form of ohm, so need not to do. Now I am going to copy. For copying two components, just select it and copy to the clipboard. Again, then paste it. It's a method for doing fast way. Again, copy. Okay, done with it. As I had told you previously, microcontroller has now for reset, sorry, for ground, you have to place ground. Without ground the circuit will never complete. Please don't forget to place it ground. Now your hardware circuitry is completed. Now you have to write the software. For software I am using the AVR Studio 5.1. See here, it's a AVR Studio 5.1. It's very quite simple. It's a freeware also. You can download it from, just Google it and you find the download section from the website and you can download it. For new project, we have to click on a new project. It's taking its time. We have to select AVR GCC C executable project. First of all, you have to select in which language you are going to code. I am just using the C language, so I have selected the C executable. If you want to code in C++, you can C++. If you want to use some HTML boards, you can just select it from here. As you see, many boards released by HTML, you can select it from here. If you have your own board, you can just write the firmware and you can select it from here. If you want to write in assembly code, you just select AVR assembler projects, and I'm just writing in C, so I have done this. From here you can change the directory where you have to save your project. I'm just saving it on desktop, AVR development editing in code. selected, and I just rename my project as LED blink. Then click OK. Now another dialog box will appear and it will show you to select on which microcontroller you are going to code. There are many families like Tiny AVR, Mega, X Mega, but our microcontroller AVR Micro 16, AVR 16 microcontroller, it's came in a Mega family, so we have to select AVR 16 at Mega 16. So, selected. Now it will generate a new window, a new file for you to write the code. Here you can see as the file appears here. It's first, see here in the corner, LED blink .c. It's a C file as you are seeing here. It's just include as normal C. In what we do, we have to hash include stdio.h so here you have to include hash include AVR IO input output peripherals, and it's just a name in that while one for a continuous loop. For while one it will run till the loop will be true. Then if we write here 1, then the loop will be always it's you can say also continuously. So we have right now we have to write the code. As you know, if you refer to the data sheet, you are going to find that AVR is a byte addressable. So you have to do every coding, or you have to access every peripherals in a byte addressable mode. So first you have to set the direction of whether it is output pin or it is input pin. So you can do it by data direction register, setting data direction register, that is set from DDR. Which port we are using? We are using, as you know that we are using port D here. So we have to define that port D. DDR D equal 0x. We are writing here in hex file. You can also write in binary. 0x means the port is configured as output port. The port is configured as output port. Now we have tried now what the signal comes to that pin, it will directly goes to the LED. We are not able to give some input like suppose that in CRO or function generator is there, you want to give some signal, it is not possible. If DDR is high, if DDR is low, it is configured as input. We will see in the later codes, in the later videos. Now if you want to just continuous blink after some duration, you will LED. So you have to simple give a command to the port that high and low, toggle the LED. So what you will do, port D. It's a very good pretty function in AVR Studio. The coding seems to be easy. You need not to write much more codes by your, it's automatically gives you peripheral. So I love this function in this one. Port D equal 0x. Port is here. Now we have to provide something delay first. If we don't provide delay and we write this way, port 5 port D equal 0x. If you write like this, the code is nothing wrong, but you are unable to distinguish that whether the LED is on or off. It seems to be continuous on because it works in a microseconds. So you are not able to distinguish. Let's see what happens. Just compile the code to generate the hex file of this. See here, successfully built. It's nothing wrong with this code, but when you implement it on the hardware, what it is going on? For feeding the hex file, just double click on the controller. It will open a dialog box that is edit component. You have to just feed here. Go to that directory where you have placed the code. LED link. Code LED link. Debug hex file. Okay. Now just run the code and see whether what happens. See, it seems to be continuous one. Why? Because it's due to some error. See here, error message came. Simulation is not running in real time for accessibility because you have not given any delay function to delay it. So it's maybe destroy your circuit. So please avoid this one. Just stop it and again simulate your code using delay. For delay, this simulator has given you an inbuilt function which is called the delay as include, which is in util package util/d. You can also make your own .h files that I will discuss in the later videos. For using this predefined function, you have to use underscore delay underscore ms and give 200 millisecond of delay for this one, and after that again 200 millisecond of delay. Again compile the code. Now you can see here in the bottom that the simulation is not running on excessive load. It's quite easy. It is running only 4% of the CPU which is using also, and see whether it is running quite good. No any error comes here. So if another method of coding is also, this is a hex way of representation or coding. If you want to do in a binary way, suppose what I had told you in a TDR, if you want that some of the part is output or input, just simple do that 0x f0. What it means, the higher bit of that port is output and the rest of the input, so it will not affect when the LED will not glow, because LED is an output device, not an input device. So see what happens here. That's right. See, only the higher bits, what D7, D6, D5 and D4 are working, rest of are as configured as an input, so it is not working. You can also configure or write the code in a binary representation like this way. 0B 1111 for higher one, or do it for output port 111. Okay, and I used to change it here so that you can see something different. You can make for higher bit 111 and then 0000, and here the higher bits are off and the lower bits are on. Let's see what happens. Sorry, something went wrong. We missed here 0x, it should be 0b. So we have check whether we have not done the wrong thing. So this nice is working. For any further questions, you can just comment in the comment box, or you can just mail me. I will try to find that the solution. I'm going to post some more videos regarding LCD interfacing, keypad, matrix interfacing, I2C, SPI, and all the steps in the later videos. And keep watching. If you like this video, please like and subscribe for more newer videos we are going to post for latest update. Thanks for watching.